let me start this class, that is a semiconductor physics. The topic is semiconductor physics. You can see that the meaning of semiconductor is nothing but a partial conductivity. What is the meaning of conductivity? The meaning of conductivity is flow of charges. Fine. So semiconductor physics we are dealing. To understand that semiconductor physics, we need to talk about what is known to be as a band theory of solids. To know band theory of solids, we need to know what is band. It's not like your musical bands. It's a band, not a friendship band or any rubber band. It's a band meaning. This band meaning is it's a group of energy levels. What is energy level? When you consider an atom, it has got its own number of orbits. Those orbits has got a different energies. Particular orbit has got a particular energy. And those orbits, if they are imagined to be in the straight line form, the group of energy levels having nearby values of the energies constitute energy band. Okay, remember what is energy band? Group of or a set of or a bundle of energy level is called energy band. So each and every atom has got energy band. Fine. So now let us discuss about the further topic in band theory. In a previous class, we discussed regarding the band theory of solids only. We saw many distributions of energies in the different directions and how the free electrons moves in solids, especially in conductors. Free electrons, many free electrons are there which are going to move in a interatomic space randomly and they are colliding with each other. These are all topics we learned in a previous class. Now I am dealing with that connection of band theory of solid to the explanation of semiconductor physics. I am repeating, what is energy band? Set of energy levels gives rise to energy band. There are two types of energy bands. Which are those? Conduction band and a valence band. Try to understand. So conduction band and a valence band. So group of energy levels, energy states, energy levels gives rise to conduction band and a valence band. Try to understand conduction band and valence band. Let us define them individually. What is conduction band? The band which is there in a upper region and which consisting of conducting electrons, which consists of a conducting electrons. The band, energy band which has got a conducting electrons and it is on the upper region of your complete structure of atom. Okay. The next is going to be valence band. What is valence band? Valence band is also an energy band in which we see valence electrons are present. Valence electrons. Fine. The electrons which are present in conduction band are participating in the conductivity. Remember well enough. So this was regarding conduction band and a valence band definition. The next is about the classification of solids on the basis of this band theory. This band theory explains that solids are categorized into three groups: insulators, semiconductors and conductors. This is the classification which was learned by you all in your lower classes only regarding insulators and conductors. Commonly, the common people also talk about conductors and insulators. What you know in common regarding the conductors and insulators is insulators are the materials which does not allow the current to pass through them. And conductors are the materials which can allow the current to pass through them completely. Metals you give as an example for conductors: rubber, fine, glass, wood, paper, you give example for the insulators. Whenever you have some short circuiting at your home, you want to switch off the main. When you want, you are running towards that main switch, and if you want to switch it off, at that time you will search for the stick, you will search for your slippers, fine, slippers to wear and stick to hit and just switch it off. Remember, what is wood? Stick is made up of wood. That is an insulator which will not conduct that short circuit electricity to you. And slippers are avoiding, they are avoiding the electron to pass through you to the earth. Fine. So human body is a conductor, don't forget about that, right? So this is about that what I'm talking here. Conductors and insulators were known to you before. Now the middle classification comes, which is there in PUC second year also, as a semiconductor electronics. Okay. Try to understand well enough, students. The name semiconductor itself gives you the information that partially conducting, semi, half, partial. Semiconductors are partial conductors. Okay. These are used in digital electronics. These are used in digital electronics. Remember well enough, these are used in digital electronics. Digital electronics, every machine which makes use of digitality. So digital electronics makes use of this particular semiconductors. In semiconductors, examples comes. So here I said in conductors metals, here insulators we said about rubber and wooden things, and in semiconductors mainly we take of silicon. Try to remember well enough, students. Silicon, silica, silicates, these are the elements which are taken from your sand. Sand, fine. From sand we can extract the silica, where we can get it silicon. And everyone know about that Bangalore is known as Silicon City, and it is also known as Electronic City. Why it is called like that? A particular area in that is called as like this. Why it is called like that? Because you know already, it's also called as IT hub also. There some companies are there which are manufacturing this digital calculators, digital appliances, digital instruments. By making use of semiconductors, especially in semiconductor, they are making use of silicon. So that is called Silicon City. Because of that, it is getting that name, or Electronic City. Okay. So try to understand well enough what I am discussing here. So such a silicon belongs to the category called as semiconductor. Called as semiconductor. So semiconductor. What is a semiconductor? Partial conductivity, but we cannot write like this in exam. What are semiconductors? The materials which lie between, the materials whose conductivity lies between insulators and conductors are called semiconductors, or the materials which allow the current to pass through them partially are called semiconductors. Okay, remember well enough what I am saying here. So now a very important one mark question comes as, what is energy gap or a forbidden energy gap? Forbidden, like it's not allowing. Forbidden energy gap, fine, or simply called as energy gap, or simply called as band gap. The gap between two bands. Which two bands are seen in all the three diagrams? I have driven the diagram for all the three solid materials: insulators, semiconductors and conductors. You can see over that. Fine. So based on the value of energy gap, based on the band gap, we are classifying these as a classes in solids. Based on conductivity also we can say, based on the energy gap also we can say. Okay, try to remember well enough. Now I am discussing regarding what is band gap. One more question, what is band gap or energy gap? The gap between valence band and conduction band. Valence band and conduction band. The gap between valence band, which is there at the bottom, and conduction band. The gap between valence band and conduction band is called as gap, called band gap or energy gap. Band gap or energy gap. Try to understand well enough. This is a gap which is measured in terms of distance. And distance is also already measured in terms of, all you know about the measurement of distance or length is in terms of meter or centimeter or micron meter and so on. But here in this category, in this concepts, we understand that at nuclear level, atomic level, the distance is sometimes measured in the form of energy required to cross the distance, energy required to jump that distance or travel that distance. So here similarly, the gap is measured in terms of electron volt. What is the value of electron volt? 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. This much of energy is required for an electron to jump from one band, bottom valence band, to the upper conduction band. Okay, how much energy is required? Based on that, band gaps are going to be mentioned in terms of EVs, electron volt. They are not writing in terms of centimeter or meter. They are writing in terms of how much energy is required to jump that distance, or a height I can call. Okay, so remember well enough, that is I'm defining the energy gap once again. The band gap is defined as the gap between, or the distance between, valence band and conduction band. This much only is that, denoted by Eg, E suffix G, it is denoted by Eg, and you can see over there. Now let us discuss each these categories in detail. Then we will go with your semiconductor further in detail again, as our topic is semiconductor physics. So here is that I am talking about this topic, insulators. What are insulators? Every common person know about that insulator. Who knows about the science, what I can say? Fine. Insulators. I drew band energy diagram, band diagram or band energy diagram for all the three. But I am discussing one by one. In the first, I am taking the insulator case. Insulators. Let us discuss the definition. The materials which does not allow the current to pass through them are called insulators. Examples: rubber, plastic, wood, etc. What makes them to be called as insulators? Insulators are also solids. They too have a energy bands. They too have a valence band and they too have a conduction band. But there is a large gap between valence band and conduction band. There is a large gap between valence band and conduction band. Remember well enough. And I wrote here, this energy gap is greater than 3 electron volt. Electron cannot jump from this valence band to conduction band. Electrons does not jump from valence band to conduction band, remember well enough. So here, in normal temperature, in room temperature, insulators always has got valence band is filled with electrons. Valence band is always filled with electrons in case of insulators. Conduction band is always empty. Conduction band is always empty. Conduction band is such a place, if once the electron enters there, this starts to participate in conductivity. When there is no sufficient energy for your electrons in valence band to jump towards this conduction band, they are not reaching conduction band, hence the conduction band remains empty. Where there are no electrons in valence conduction band, there is no conductivity. Who should participate in conductivity are not there, are absent here. Conducting electrons are absent, so conductivity is also absent. Hence, take a wooden stick and burn it. Fine. It can burn itself and give ash and coal. Fine. It starts to give you the charcoal. It becomes dark. It starts to burn continuously. Fine. What is happening there? Heat is getting transferred. If you take a stick and just hold it towards the electric circuit where current can be passed, is that electricity is going to be coming towards you? No. It is making that portion which has come in its contact to be getting heated. The tip of your wooden stick which is there in a socket is getting heated. And once current starts to just accumulate there only at the tip, short circuiting takes place in the socket itself. Short circuiting takes place in the socket itself. Nothing happens to your what you can call as a wooden stick. Only it can be seen like a dark in color, little burning or burnt. What I can say, little burnt. Fine. So I'm talking about the insulators. Miss, if I increase the temperature, what happens? You may be thinking like that. Even though if you increase the temperature, there is no one electron goes from valence band to conduction band. Hence, whatever you do, there is no conductivity. Fine. This is the case of your insulators. Right. Let me discuss about the conductors, then I will come back to the semiconductors. Why means this semiconductor topic is there in still detail for your syllabus. So, let me wind up this small portion, then we'll go with the detailed portions. Right. Conduction band and valence band. You can see there is a overlapping. Conductors. The materials which allow the current to pass through them completely are called conductors. Example, copper, iron, fine, maximum metals, not all metals, maximum metals we say. Okay, copper, iron, silver, aluminium, fine. So concentrate well enough. So conductors definition and their example. The next case. In energy band gap, there is no value at all. There is no gap between conduction band and valence band. How many valence electrons are present? All will go towards the conduction band. It is like almost connected to one another. Just they are jumping. Easily they are jumping, easily they are moving from conduction to valence, valence to conduction. Remember well enough. Valence electrons are easily going in conduction band and they easily pass as a conducting electrons and your conductivity is on. Conductivity starts to take place now. The electrons are playing a role of conductivity. They are playing role in a conductivity. So energy gap is zero. There is overlapping of your conduction band and valence band. Hence valence electrons are easily moving towards the conduction band. Hence conductivity is possible. Hence these are called conductors. There is a good conductivity in conductors. Clear? This is about conductors what I am discussing here. So examples, definitions, energy gap, no gap at all, overlapping is there. If we increase the temperature, what happens? That time the electrons still move faster. They will jump from valence band to conduction band, many in number, more in number. Okay. The next here, this is about a conductors. Temperature decrease or increase, there is an increase or decrease in conductivity. That's it. If you decrease the temperature, electrons will be just sitting here and there. They are not going towards the conduction band. Hence, there is less conductivity. Take a metal rod and heat from one end, or you cannot do this experiment. What I can say here, only you can imagine. ಅಪ್ಪಿ ತಪ್ಪಿನೂ ಮಾಡಕ್ ಹೋಗ್ಬಾರ್ದು. ಜಸ್ಟ್ ಅಷ್ಟೇ ಆ ವುಡನ್ ಸ್ಟಿಕ್ ಏನ್ ಇಟ್ಟಿದ್ರಲ್ಲ ಸಾಕೆಟ್ ಅಲ್ಲಿ, ಆ ತರ ಈಗ ಮೆಟಲ್ ಸ್ಟಿಕ್ ನ ಯಾರು ಇಡೋ ಧೈರ್ಯ ಮಾಡಲ್ಲ. ಚಿಕ್ಕ ಮಕ್ಕಳ ಗೊತ್ತಿಲ್ಲದೆ ಇರೋರು ಇಡ್ಬೇಕಷ್ಟೇನೆ. ಇಟ್ಟು ಏನ್ ಮಾಡ್ಕೊಳಂಗಿದ್ದಾರೆ, ಶಾಕ್ ಹೊಡ್ಕೊಳಂಗಿದ್ದಾರೆ. Nobody is going to just do that. You know, your testers are made up of backside fiber ones and front it will be having a metal portion. Testers ಸ್ಕ್ರೂ ಡ್ರೈವರ್ ಟೈಪ್ ಅಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಟೆಸ್ಟರ್, ಒಳಗಡೆ ಒಂದು ಬಲ್ಬ್ ಇರುತ್ತೆ, ಗ್ಲೋ ಆಗುತ್ತೆ ಕರೆಂಟ್ ಪಾಸ್ ಆಗ್ತಿದ್ರೆ ಅದನ್ನು ತೋರಿಸೋದಕ್ಕೆ. ಸೊ what I want you to understand is easily the metals are conducting. They are called conductors. ಹಿಂಗ್ ಹೋಗ್ತವೆ, like this they are going, right? Then next come back to the main topic, semiconductors. Interesting topic. Semiconductors, the materials which allow the current to pass through them partially are called semiconductors. Example, silicon and germanium. Okay. So there is a less gap between conduction band and valence band. There is less gap between conduction band and valence band. And you can see that the value is also written here. The energy gap is less than 3 electron volt. If it is 0, then they are called conductors because they have many conducting electrons which will conduct electricity. If they have value between 0 and 3 electron volt, they all has got a little or a less energy gap in which some electrons are capable of jumping that gap and reaching the conduction band. When they jump and reach the conduction band, they will participate in conductivity. Remember well enough what I am saying here. So, partially filled, partially empty. Because some electrons are here, some electrons are there. So, it is partially conducting, hence called as semiconductor. Energy gap is less than 3 electron volt. Okay. And very important thing is, what happens on increasing temperature? Is this case remains always same? Is this metal, is this semiconductor silicon or germanium is at room temperature, partially filled, partially empty, conduction and valence bands are seen here. If once the temperature starts to increase, what happens in that semiconductor or silicon or germanium? Try to understand well enough what I am discussing here. Once you start increasing the temperature, the electron in the valence band gains energy, heat energy, and many more number of electrons starts to jump towards conduction band, and they will jump in such a way that this energy gap starts reducing in its height or a distance or length, and almost it behaves like a conductor. How can I say in a simple sentence? Semiconductor behaves like a conductor at high temperature. ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಕ್ಲಾಸ್ ನಡೀತಾ ಇತ್ತು, ರೆಕಾರ್ಡ್ ಕೂಡ ಮಾಡಿದೆ